Hello friends, welcome to Maths Practice. In the previous video we had discussed the pair of linear equation in two variables, the method to solve the pair of linear equation in two variables with the help of examples. I will give the link of the video in the description box. Now in this video we will discuss the practice examples for solving the pair of linear equation in two variables. Example 1. 10 students take part in a class 10 Olympiad examination. The number of girls is 4 more than the number of boys. Find the number of boys and girls who took part in the exam by the graphical method. Let x and y be the number of girls and boys who took part in the exam. Means x is the number of girls and y is the number of boys. Now the pair of linear equations will be, first of all, the total is 10. So x plus y is 10. Second equation is the number of girls, which is x is 4 more than number of boys. So y plus 4. X is equal to y plus 4 or x minus y is equal to 4. Now the table of points for first equation, x plus y is equal to 10, means y is equal to 10 minus x. Let x is equal to 0, we get y 10. If x is 10, we get y as 0. Now you can obtain any 2 points for the line. Now the table of points for y is equal to x minus 4. Now if we take x is equal to 4, we get y is equal to 0, and if we take x is equal to 0, we get y is equal to minus 4. Now when we graph both of these lines, we will see that they intersect at the point 7, 3. Means the answer is 7, 3. The number of girls is 7 and the number of boys is 3. Let us see the graph. In the graph, we can clearly see that both lines intersect at the point 7, 3. So there is a unique solution. And the solution is at the point 7, 3. Means the number of girls is 7 and the number of boys is 3. In the example 2, the cost of table is thrice the cost of a chair. The total cost of 4 chairs and table is 2100 rupees. Find the cost of a table and the cost of a chair by the method of substitution. So here we are said to use the method of substitution. Let x and y be the cost of a table and a chair respectively. So first it is given that the cost of table x is 3 times y, the cost of a chair. And in the second case it is given total cost of 4 chairs and a table, means x plus 4y is rupees 2100. Now since we have got two equations and we have to use the method of substitution, from the first equation it is very clear x is equal to 3y, which will substitute in the second equation. So hence we get 7y is 2100 or y is equal to 300. Now we substitute this value of y 300 in x is equal to 3y. So we get x is equal to 900. Means the cost of the table is rupees 900 and that of a chair is rupees 300. Example 3. A lending library has a fixed charge for the first 3 days and an additional charge for each day thereafter. Saritha paid rupees 27 for a book kept for 7 days, while Seema paid rupees 21 for the book she kept for 5 days. Now from this, find the fixed charge and the charge for each day and by the method of elimination. Now first of all, assume that the fixed charge is x and the charge for each day is y. So in the first case, the fixed charge is x. For the first 3 days, it is the fixed charge, which is x. Now she has kept the book for 7 days. So after 7 minus 3, the remaining number of days is 4. So for the 4 days, the additional charge has to be paid. So fixed charge x plus the additional charge for 4 days, which is 4y, total is equal to 27. Similarly, in the second case, Seema has kept the book for 5 days. So for the first 3 days, it is fixed charge x, and for the remaining 2 days, it will be 2y. So x plus 2y is equal to 21. Now we have obtained the two equations. We will use the method of elimination. In elimination method, we have to make the coefficient equal for any one of the variables. Since here both are same, the coefficient of x is 1 in first and second equation both, we just need to subtract the second equation from the first one, which will give us 2y is equal to 6 or y is equal to 3. We substitute y is equal to 3 in the first equation. X plus 4y is equal to 27. Hence we get x is equal to 15. So what we have obtained is the fixed charge is rupees 15 and the additional charge per day is rupees 3, and we have used the method of elimination here. Example 4. A fraction becomes 1 upon 3 when 1 is subtracted from the numerator, and it becomes 1 upon 4 when 8 is added to the denominator. Find the fraction by the method of cross multiplication. So first of all, assume that the numerator is x and the denominator is y. So when 1 is subtracted from the numerator, means x minus 1, the fraction is x minus 1 upon y equal to 1 upon 3. Now this will give us 3x minus y minus 3 is equal to 0. Remember, you have to write it in the form of ax plus by plus c is equal to 0 for this method. Similarly, in the second case, it becomes 1 upon 4 when 8 is added to its denominator. So the numerator is x, but 8 is added to denominator, so it will become y plus 8. The fraction is x upon y plus 8, which is equal to 1 upon 4, which gives us 4x minus y minus 8 is equal to 0. So now we first list down all the coefficients. A1 is 3, B1 is minus 1, C1 is minus 3, A2 is 4, B2 is minus 1 and C2 is minus 8. The method of cross multiplication for x upon, we write the coefficient ignoring x, that means the remaining coefficient. So we will write B1, C1 and B2, C2, which is minus 1, minus 3, minus 1, minus 8. Similarly for y, we ignore B1 and B2 and write the remaining coefficient in order. So first we will write C1 minus 3, then C2 we will write down, which is minus 8. And similarly A1 is 3 and we write A2, which is 4. So y upon minus 3, 3, minus 8, 4. Similarly for the constant term, it will always be 1 upon, we ignore C1, C2. So we write 3 minus 1 and we write 4 minus 1. Now we just solve the determinant, that means we cross multiply x upon minus 8 into minus 1 minus minus 1 into minus 3, so which will give us 8 minus 3 or 5. So x upon 5, and the right hand side is 1 upon minus 3 minus minus 4, that means minus 3 plus 4, that is 1. So 1 upon 1 is 1. X upon 5 is 1, and similarly y upon 12 is also 1. So we get x is equal to 5 and y is equal to 12. So our fraction is 5 upon 12. Example 5. A boat goes 21 kilometers upstream and 18 kilometers downstream in 9 hours. In 13 hours, it can go 30 kilometers upstream and 27 kilometers downstream. Determine the speed of the stream and that of the boat in still water. So we will assume that the speed of the boat in still water is x kilometers per hour and the speed of the stream is y kilometers per hour. Now these are some important formulas, remember them. The speed of the boat downstream the speed will always be more. It will be equal to the x plus y, means the speed of boat in still water plus the speed of the stream. And when the boat goes upstream, the speed will be less. It will be x minus y, means the speed of boat in still water minus the speed of the stream. Remember, downstream x plus y, upstream x minus y. Speed is distance upon time, so time is distance upon speed. Now, in the first case, when the boat goes 21 kilometers upstream, let the time taken be t1 hours. So time is distance upon speed. T1 is distance 21 upon speed x minus y because it is upstream. In the first case itself, when the boat goes 18 kilometers downstream, let the time taken be t2 hours. So again over here, time is distance upon speed. T2 is equal to distance, which is 18, upon speed, which will be x plus y because it is downstream. So from the first case, what we get is T1 is 21 upon x minus y, T2 is 18 upon x plus y. The total time is 9 hours. So 21 upon x minus y plus 18 upon x plus y will be equal to 9. This will be the first equation. Similarly, in the second case, when the boat goes 30 kilometers upstream, let the time taken be t1 hours. time is distance upon speed, and since it is upstream, the speed is x minus y. So t1 is 30 upon x minus y. In the second case itself, when the boat goes 27 kilometers downstream, let the time taken be t2 hours. So again t2 is equal to 27 upon x plus y because it is downstream. Total time is 13 hours. So 30 upon x minus y plus 27 upon x plus y is equal to 13. Now we have got two equations. Remember, in the last video we had seen how to reduce it to a pair of linear equations. So over here, for simplicity, we take 1 upon x minus y as a and 1 upon x plus y as some variable b. So now we get the simplified pair of linear equations, which is 21a plus 18b is equal to 9, or simplified 7a plus 6b is equal to 3. And the second equation is 30a plus 27b is equal to 13. Now we can use any method to solve this. We will be solving it by the method of elimination. Now we have obtained two equations, 7a plus 6b is equal to 3 and 30a plus 27b is equal to 13. Now for the method of elimination, we know we have to make the coefficient for one of the variables equal. Here we can make the coefficients for b equal by multiplying the first equation by 27 and second by 6, or for simplicity, since both are divisible by 3, instead of multiplying by 27 we multiply by 9, and instead of multiplying by 6 we multiply by 2. So multiply the first equation by 9 and the second equation by 2. We get 63a plus 54b is equal to 27, 60a plus 54b is equal to 26. The coefficient of b is same in both the cases, thus subtract the second equation from the first equation or reverse the sign. So what we get is 63 minus 60, which is 3a, is equal to 27 minus 26 is equal to 1. So a is 1 upon 3. Now substitute a is equal to 1 upon 3 in the any one of the above equations. Say 7a plus 6b is equal to 3. We get 6b is equal to 3 minus 7 by 3, or b is equal to 1 upon 9. But we know that 1 upon x minus y was our a, which is equal to 1 upon 3. So x minus y is just 3. Similarly, 1 upon x plus y is equal to b, which is 1 by 9, or x plus y is 9. So now again what we have obtained is x minus y is equal to 3 and x plus y is equal to 9. You can add both of these equations. You get 2x is equal to 12 or x is equal to 6. Substituting this, we get y is equal to 3. So what we have obtained is the speed of the boat in still water is 6 kilometers per hour and the speed of the stream is 3 kilometers per hour. Example 6. Find out whether the following pair of linear equations is consistent or not. Also state whether they intersect at a point, are coincident, or represent parallel lines. 3 upon 2x plus 5 upon 3y is equal to 7. 9x minus 10y is equal to 14. Now first of all list down all the coefficients. We have listed down a1, b1, c1, a2, b2, c2. Now a1 upon a2, this ratio is equal to 1 by 6, b1 upon b2 is minus 1 by 6 and c1 upon c2 is half. So first of all a1 upon a2 is not equal to b1 upon b2. So obviously they are consistent and they represent intersecting lines. Therefore there will be one unique solution. Second example, 2x minus 3y is equal to 8, 4x minus 6y is equal to 9. Remember over here 2x minus 3y is equal to 8 means 2x minus 3y minus 8 is equal to 0. That means your c1 is minus 8. Similarly c2 is minus 9. Always convert in the form of ax plus by plus c is equal to 0. Here a1 upon a2 is half, b1 upon b2 is also half, but c1 upon c2 is 8 upon 9. That means over here we have seen last time that the condition a1 upon a2 is equal to b1 upon b2, but both are not equal to c1 upon c2. That means the system is inconsistent. They represent parallel lines. They will never intersect. So there is no solution. Third example. 4 upon 3x plus 2y is equal to 8. 2x plus 3y is equal to 12. Means a1 is 4 upon 3, b1 is 2, c1 is minus 8, a2 2, b2 3 and c2 is minus 12. So here the ratios a1 upon a2 is 2 by 3, b1 upon b2 is also 2 by 3 and c1 upon c2 is also 2 by 3. Means here a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. So they are consistent and they will represent coincident lines, means they will represent the same line. So all the points on the line will be solution. It will have infinitely many solutions. 6x minus 3y plus 10 is equal to 0. 2x minus y plus 9 is equal to 0. We have listed down a1, b1, c1, a2, b2 and c2. a1 upon a2 is 3, b1 upon b2 is 3, c1 upon c2 is 10 upon 9. Means here again a1 upon a2 is equal to b1 upon b2 but not equal to c1 upon c2. So they are inconsistent, they represent parallel lines and they will have no solution. Example 7. 5 women and 2 men together can finish a task in 4 days, while 6 women and 3 men can finish it in 3 days. Find the time taken by one woman alone to finish the work. Also find the time taken by one man alone to finish the work. Remember, these are important examples. Many a times they are asked. So what we have to find out, let x be the time taken by one woman alone to finish the work and y be the time taken by one man alone to finish the work. So 1 upon x work will be done by one woman in one day and similarly 1 upon y work will be done by one man in one day. 5 women means 5 into 1 upon x plus 2 men plus 2 into 1 upon y. Finished in 4 days. So in one day it will be 1/4 task. So 5 upon x plus 2 upon y is equal to 1 upon 4. Similarly 6 women means 6 upon x plus 3 upon y. In 3 days means in one day 1 upon 3. Now we have two equations. So we just have to reduce in a simpler form. Let 1 upon x is equal to some variable a and 1 upon y is equal to b. So now we have set of equations 5a plus 2b is equal to 1 upon 4. 6a plus 3b is equal to 1 upon 3. This is how these type of examples are done. Now we will solve this pair of linear equations. We will solve by the elimination method. So we can make any one of the coefficients equal, means the coefficient of any one of the variables equal. Here we can multiply the first equation by 3 and the second equation by 2 so that the coefficient of b will become equal. So now we have 15a plus 6b is equal to 3 upon 4, 12a plus 6b is equal to 2 upon 3. Just subtract the second equation from the first. So we get 3a is 1 upon 12 or a is equal to 1 upon 36. Now substituting the value of a, we get 2b is equal to 1 upon 9 or b is equal to 1 upon 18. Now a is 1 upon x, so x is 36 and b is 1 upon y, so y is 18. Hence the answer is 36 days will be required by one woman alone to finish the work and 18 days will be the time taken by one man alone to finish the work. Friends, we have solved all important types of examples for this chapter. Now some assignment examples. In the first one you have to solve the pair of linear equations. Now again here you have to reduce in a simpler form, but what you have to do is you can take 1 upon x plus 1 as a and 1 upon y plus 2 as b. So it will be reduced in a simpler form. The answer is 3, 5. Second one, a number consists of two digits. When the number is divided by the sum of its digits, the quotient is 7. If 27 is subtracted from the number, the digits interchange their places. Find the number. You will be getting a pair of linear equations, but for that first you have to take a two-digit number. And how do you express a two-digit number? 10x plus y. So if you have, for example, 63 is the answer, means it is 10 into 6 plus 3. So you start by taking the number as 10x plus y. Third one, solve the pair of equations. X upon a minus y upon b is equal to 0. Ax plus by is equal to a square plus b square. Now you have to simplify this and use the elimination method. Simplify this means you have to x upon a minus y upon b. So you can have xb minus y is equal to 0. Similarly the second equation. then you can make the coefficient of one of the variables equal, x or y, any variable, and then use the elimination method. You will get the answer as x is equal to a and y is equal to b. Hope the examples were well understood. You can share your comments, and also the link for the key concepts of this chapter, key concepts on linear equation in two variables, will be shared in the description box. Please do like and share the video and subscribe to this channel Maths Practice. Thank you.